this, and we have to do one more thing, the reinforcement learning replacement, namely EPO. Yeah, those are the two topics we do. So let's go back to, did it happen? Where did could one of you verify if the live streaming has started? I seem to have absent-mindedly closed it.
It says meeting is
It works. Live streaming works.
Okay, thank you. So guys, we have been doing a lot of fine-tuning. There is one more topic in fine-tuning. Actually, let me do that topic before. All this fine-tuning is supervised fine-tuning, isn't it? SFT. But remember that now I mentioned that in our journey, there with LLMs, there is one more animal in the zoo. What is that? It is the human preference alignment, right? The human preference alignment, or the alignment problem, is huge. It is both necessary and an ethical responsibility. So, like that picture showed in the beginning, you have a monster that you gradually domesticate into a cute little animal. So from that perspective, is the reinforcement learning on human feedback. Initially, people thought that you need a reward model, and you can train a reward model based on the human feedback, and then do the policy optimization, right? Because policy optimization will admit your gradient descent and all of that. You could do all of that. People were doing it because it just seemed natural until this paper came along, and this paper questioned it all. It was a surprise, actually. And this paper makes a statement that is so dead obvious that you look back, again, one of those beautiful breakthroughs, that you look back. Oh, I haven't given the link to the paper. Let me give the link in the other place. Yes. Direct preference optimization. Let me see if I put the paper there. Oh, here also I haven't put the paper. I will put the paper here, guys. Huh? It is literally called direct preference optimization. I strongly encourage you to read that paper. It's important. I think I have put the paper in the course. In the foundational papers, it may be there. Let me make sure that I have it. No, I haven't done it there either. That's bad of me. I'll fix that. Let's go down to DPO. I'll give you the main idea of direct preference optimization, but I leave for you the reading of the paper and watching of the YouTube. Now, guys, I know that I'm asking you today to watch at least 2 more YouTube videos, that my prior sessions. We are trying to move faster now. And so you have to do some bit of what is called flipped classroom. You study and then come with questions if you have. I wish I had the time to explain this paper in great detail, because this has been, again, a milestone research paper. What it says is that you don't need reinforcement learning. In fact, it says that of the 2 things, the reward model is implicitly present if you do your math a certain way, and you can do a direct preference optimization. Preference is what? Preference, human preference. You can do a direct gradient descent on the preference optimization, right? So that is where the word direct preference optimization comes in. And doing that, let me see if I can, in the video itself, show you. Backing up. That's the only way it produces. Yeah, I think there's some I would say, of course, at the end, I'm told that if they look. Okay, so now that I look at this recording, session that I gave a few months ago, I remember that I explained it in great detail, and I think you'll find it easy to learn. Right? So PI is the preference policy optimization that you see on the screen here. Read it on your own if you feel. So I'll leave you guys with the message. If you want, next time I will cover it carefully. Like if you feel that it is not clear, I will cover it carefully. Is that fair? Right? But its main contribution is it questioned whether we need RL at all. And it said there is a way without it. In fact, it makes it into yet another simple cross entropy loss function kind of gradient descent exercise. So DPO is being applied. People still consider it. So the vocabulary has gotten a little bit fluid. People now look at DPO as a RL method, as a method of reinforcement learning, which it isn't, but it's sort of a way of looking at it. They say that, hey, there is supervised fine-tuning and reinforcement learning, and there is a new kid in the block on the reinforcement learning side. It is the DPO instead of the PPO, which used to be the proper RL way of doing things. So that is one change that has come out. Again, it's an important paper. Please do watch this video and take the quiz. I'll post the quiz. Can I please request all of you to take the quiz? Do take the quiz, and I will update the paper. The reason I'm being brave is because you guys requested that I finish all of fine-tuning in one day, the remaining, and I'm trying to do that. But it needs a lot of initiative from your side to catch up on this, please. So GaLore is the last topic. It is not so much about fine-tuning. It asks a different question. It says that LoRa made it possible to fine-tune models on commodity hardware, isn't it? Right? Commodity is still, like, in quotes, 4090 is still expensive, right? Or A6000s are still expensive. A couple of 4090s or A6000s are expensive. By the way, fine-tuning still, like when people say that I have a server with 8 A100s, therefore, and I was able to fine-tune on it, people will still congratulate you that you were able to fine-tune on so little resources. Right? it's all the, as they say, beauty is in the eyes of the beholder. So it depends on how you look at it. Right? So I wouldn't dare go purchase that. Right? So now let's look at the same argument. People said, if you can do it with fine-tuning, can we not apply a similar argument to the full training of the model? Why not? Right? Can we not apply LoRa-like arguments to the entire full tuning? So now, so I'll give you the main arguments, and then, if needed, I'll do a session. Actually, I will do a session on GaLore, but in the interest of time, I'll make it a Wednesday paper reading, guys. Is that fair? Yeah. I'll make it a Wednesday paper reading. So what is GaLore trying to say? And again, the big ideas. I won't go into the technical details. What it says is, see, imagine that you have a big model. Let me use another color because this is a boundary. Okay, so suppose you have a big model, lots of weights and biases, lots of parameters. Let's say 7 billion parameters or something like that. Can I, or a 70 billion, let's take even more, 70 billion parameters or 7 billion. See, you realize, guys, that you can't pre-train even a 7 billion parameter model on your 4090. Why? It needs twice the memory. Right? We saw that, right?
Three times, right? 3 times.
And then for each of the parameter, you need 2 bytes. Right? So 7 times 3 is 21. Double that, 42 GB. Plus overheads, 45, 46 GB, which you don't have. Right? So it's not really possible to fine-tune or to even pre-train. Like suppose you had the data to pre-train a model. Fine-tuning and pre-training have the same cost. You just do it for longer with more data, isn't it? If you do full model fine-tuning. So now the question that comes, can we apply a trick? So for example, can I initialize all the, you know that the weights are of a normal distribution, isn't it? They show a normal distribution. So people initially said, hey, you know what? Maybe there are so many weights that are close to 0, right? That beyond a certain threshold, epsilon, if weight less than sorry, if weight is less than epsilon, then zero the weight, set it to 0, right? And then the weights that remain, right, they obviously are now much fewer weights and biases, fewer parameters, and we can probably represent them with they represent a lower dimensional space, isn't it? And so, voila, LoRa is back, right? But actually, there is a problem with that. Can you guess what the problem is? The problem is you don't know which weights can you zero out, because in the beginning they're randomized, right? So now you have a problem. You know some weights are dispensable, but you don't know which weights are dispensable, right? So that brings in some head scratching, and that's why it was hard to apply LoRa to full model training. Till they started thinking about it, and they said, okay, let's do one thing. So they brought in a couple of ideas, a hierarchy of ideas. One of the ideas is, guess what? The problem is the gradient of G, the gradient of the weights, right? The gradient G, which being with respect to the weights, right? Now, we know, let the weights be what they are. But the problem with gradient is you have to look at the first and the second order gradient equation in the gradient. And that adds a lot, right? And so what we can do is we can make the assumption that the gradients form a low rank, right? What if we apply the argument not to the main weights and parameters, but to the gradients? And so is that reasonable? Let's think about it. Is that reasonable? Why would I think that is reasonable? Yes?
Is this, how would you look at, because like if the gradient is 0, then obviously the weight isn't going to change. But essentially, like, how do you know that the gradient is going to be like relatively low for like all the data points that you want to find?
Okay, so I'll give you an argument which is not really a good argument. So first, let me tell you that I'm cheating, right? Right. So, so imagine that you're looking at ReLU and you're looking at the gradient, the value at that particular moment of activations are all coming out negative. At that moment, what will be your gradient?
Oh, it's
0. So you do expect that at least, if assuming that half the numbers are negative or they're coming out like that, activations are coming out negative and positive, right? You can argue that at least half my gradients will be 0, right? So I cut the space to half now.
But then what happens if you're using like a leaky ruler for this? Would you just
it's minuscule gradients, very tiny gradient. And then you can use that epsilon thing below a threshold, I'll forget it.
Yeah, fair.
Right? So something like that. But by the way, this is not a valid argument. I'm just giving you an intuition about it, right? So given that intuition that you can have a gradient has a low rank, there is still a problem. The problem is, but what is the space in which I can represent the gradient, right? And that question, it turns out you have to keep shifting. You cannot take a fixed space and assume gradient belongs to that space. There is more careful mathematics that has to be gone through. And that math is, and that is why I said that I want to actually cover this paper in careful detail, right? But the main idea is, if I could do that, do you see that I can reduce the problem of full training of the model also? Reduce it significantly, right? And then, of course, not to forget that I can bring in my quantization. I can quantize down to 4 bits. Then when I'm computing, like, compute gradients, etc., and then push it back up. So you do this very U-shaped thing. Take things, quantize it down to 4 bits, store it, and right before the gradient, you dequantize, take the gradient, store the gradient as 4-bit, but every time you do updates, you again go back to the original space and do the gradient. Move back to 16-bit So there is all of this funky stuff that you do in this paper. But the basic thing is this paper goes all out to see, is it at all possible to do training on commodity hardware? And it comes back with the good news that you can actually. It's just lovely. This is very recent work, guys. Very recent. Can somebody check when the GaLore research paper came out?
March 2000.
Yes, it is this month.
Oh my God.
Right. This is all very recent work. Right. So you're now, I've taken you now to the cutting edge of this topic.
So we don't need LoRa.
No, LoRa is for fine tuning. This is for full model tuning. Oh, the whole model training itself. So now, if you look at this, as you can see, submitted on 6th March, 2 weeks ago, right? And does it work? I verified that it works.
What do you mean? You tried it?
Yes. And in fact, that is your homework. You must try it. Here is the code, right? So why is this misbehaving? I don't know what's happening on this machine. Reload. Yeah, it takes a little bit of time to reload, but for some reason. Yeah, so I want you guys to do one thing, guys. Before you leave, at least read this article, right? Don't read the paper. The paper reading I'll do on Wednesday. Not this Wednesday, but I think this Wednesday I've already announced the topic, but the Wednesday after that, yeah, I will do that. Or maybe if nobody has noticed the topic, I'll interchange the topic. This training. Now, I would advise you one thing. Try this on Colab with A100, just for basic. If you try it on 4090, you may succeed, you may not succeed. All right. If you have two 4090s, you'll succeed.
What if we try to turn it into like a 1.5 bit
Oh,
compression? Then I get to run it on my mouse.
So
yes. This is fun. So guys, you notice that. Let's look through this code. Torch. By now, are these all very familiar animals in our zoo? All of these? These are we are familiar with, right? Transformers and this and that. Oh, what is TRL? It's a reinforcement. This is the fine-tuning library. They're very popular. I load a data set. What is the IMDb data set? Movie reviews. Yes, movie reviews. A training argument, output directory, something max steps per device. Do you notice that batch size from in the fine-tuning we were using 32. Here the batch size is lower. 2. Why? Because we are somehow trying to survive on commodity hardware. Right? So when you have a batch size 2, you realize that we are dangerously close to stochastic gradient descent at this moment. Right? Very, very close to it. Yeah. But in any way, you still use the GaLore Atom, a version of Atom adapted to GaLore. Right? Now, what you're saying is, what are the modules you're targeting? Attention and MLP. What is Atten and MLP? What do they stand for? Can you guys guess? See, a transformer is made up of many, many things, but primarily it's made up of attention layers, attention KQV matrices, W matrices, WQ, WK, WV, and then I keep telling you that like peanut butter and jelly sandwich, like there's always MLP layers everywhere to bring in the deformation and alignment, right? So those are your MLP. So what they're saying is that go fine tune both, not fine tune, train both. So you're basically saying I'm doing a full model training, right? Model ID, you're taking a Mistral 7 billion parameter model, or pick yours. It doesn't matter which one you pick. Auto config, pick 7 billion range. From these lines of codes, are they dead obvious by now? It's familiar to you, right? Config for this model, tokenizer for this model, and here's the model, right? And then trainer, in the trainer, you load the model, right? And max sequence length comes from the limitation of the model itself, which is 512. And trainer.train, so far looks obvious, guys. Do you see how obvious it is? In fact, I would argue that if you're used to the Hugging Face loop, this is the standard loop. The only difference that you see, if at all, is this line. That is it. You use a different optimizer other than that, and then this additional parameter comes in. By the way, one caveat, to run this, you must update your transformer. So what I had to do is a pip install -- upgrade transformers.
The latest one.
Absolutely the latest one. Otherwise, this thing doesn't work, right? That is something you need to do. Right? And then, of course, install GaLore. Make sure you install GaLore. Somewhere there, it must say pip torch -GaLore. It must say that. Let me see where it says that. Pip install.
They're saying TRL.
Oh, TRL is the fine-tuning library. Yeah. Pip, this is fine. Somewhere, okay, maybe not here.
It's directly above that.
Come again?
It's directly above.
Oh, yeah. Pip install. This is the, and yeah, pip install. Here it is. GaLore torch. Sorry, I gave it the other way around. I said torch GaLore. It's GaLore.
Pressing the Python code, I don't see it.
No, it becomes implicit. Yeah. So then run it in your collab with A100 and you'll be fine. Now, if you look at the original paper, I'll just give you a glance at it, guys. So this is the bragging right. Now, you notice that what is it that they say? They're able to do, this picture is important. Figure 1, 4090's limitation is this, memory cost. This is where you stop in a 4090. And GaLore just about makes it below the 4090. Right? But it is so dangerously close to the boundary line. If you're using, a desktop UI with many things running in the background, etc., you may actually cross that. You may have a CUDA out of memory. Right? So be careful. One of the advice I give people is if you have a 4090, you should actually connect your monitors not to the 4090. What should you connect it to then? If you can, motherboards usually, some motherboard themselves have monitor support. Attach it to that, or just get a $200-300 GPU, cheap GPU, and connect your monitors to that.
Sir,
Leave your 4090 alone.
Don't give all the tricks in one class, sir.
Oh, right. Yeah. So if you do that, right, then this thing will pull through. And the complication that comes, the gradient. So you notice that it talks about the gradients everywhere. Like LoRa all the time talked about the parameters, but GaLore talks everywhere about the gradients. The gradients being low rank and this and that. Yeah. So it is the gradient that is, and gradients come in where? In the optimizer, right? It is the optimizer that will use the gradient in the second order gradient. So, which is the Adam W. And so you replace what is it that you noticed in the code? You just replace the optimizer with GaLore Adam W. Now does it make very intuitive sense why it was done like that? Right? And now this is it, learning through low rank. So what happens is you have to create multiple low rank subspaces in the iterations as you go through it in the steps. And there's a bit of beautiful mathematics here. I will explain it separately one day. But definitely take a stab at understanding it if you can. There's nothing very magical. By the way, it all starts with the equation of the Adam itself. I don't know, do you guys remember the Adam optimizer, Adam W's optimizer?
Yes,
Or should I start by reviewing that? If you want, I can review that and then go into this. Right. But basically, it's a momentum based.
I have a question for you at the end of this session. It's I think a little bit too far off from this.
Okay, we'll take it offline. Yeah. All right, guys. So this is it, and that brings me to the end. So, guys, what are our task items? You notice that. Let's go through it one by one and make sure that you remember the tasks for today. So we started the day, I believe, with lava, right? I hope you remember we covered lava today, which was a excellent illustration of how you can use fine-tuning to develop amazing capabilities for a model. It led to a lot of downstream work. It has been used. The Lava itself went from Lava 1.0 to 1.5 to 1.6. 1.6 is also called Lava Next. That's a word they use often. So this is the Lava paper. This is the Lava 1.5 paper. This is the Lava 1.6 paper, the Lava Next. Then people hybridize Lava with reinforcement learning with human feedback. Then people use Lava, fine-tune it for the medical domain. And here is this is your real homework. Your homework is to literally read this article, study it, not just read it or browse through it, but actually study it and do it. Please go do this. Right? This is homework number 1. Homework number 2 is please go and read the Lava paper itself, research paper itself. Now you should find it very easy to read, the research paper. That's your first. So guys, 2 items we said on Lava. So should I write it down as assignment? Let me write that down as assignment. Let me add an activity here. Assignment. I'll clean this up. One.
Asif, you can say as the day 7 assignment.
Call it day 7 assignment. Okay, I'll do that. No, but it is still adding to learn.
Yeah. Okay.
Day 6, yeah. Oh yeah, because I started counting from 0. Today is day 7. It's putting it as day 6. So one is read the Lava research paper. Number 2 is to read the blog on fine-tuning Lava with custom data sets and repeat the code exercise. These 2 things. So please do that, guys. Don't skip it.
And third is quiz.
And I will give a quiz also. Take the quiz. Yeah, good point. Or take the quiz on Lava. The quiz on Lava. These are your 3 main assignments for this day. So with that, we move on to the next one. This is your assignment. Let me make this assignment a little bigger and let me mark it up. Let me put it here. Or I'll put it even above the video. Why not? Oops, no, it won't let me put it above the video. All right. LLM fine-tuning methods. Here, what is your assignment? Assignment. Onslaught and Llama factory assignments. One is carefully read the notebooks on Onslaught for model fine-tuning and on story generation, short story generation. Short story generation. 2, run the code, the notebook. Run the notebook in Colab or your machine. Number 3, repeat the exercise with Llama factory. Read the paper on Llama factory. I think they have written a little paper which is very easy to understand. This is your assignment. So this is a do thing. There is no theoretical thing to understand. Here's a Llama factory paper. Let's do all of this, guys. Next is a parameter efficient. Here your assignment is left assignment. It's very simple. Read the paper on prompt fine tuning. Read the paper on the, forgetting what the exact name is. My mind is now getting tired, clearly. A PEFT IA3. IA3. You know, this is the learned vector approach, IA. Take the quizzes on both. So guys, for interest of time, I didn't cover those papers. But LoRa has pretty much become the dominant approach. Having said that, you shouldn't have the impression that perf and LoRa are synonyms. There are other approaches too. Save and display. Does this look fair, guys? So today I'm leaving you guys with a lot of assignment. And I'm worried that you guys are not doing your assignment. I don't know how much you'll do. But guys, fine tuning. So can you guess how much in the big companies a fine tuning engineer makes?
250.
2 million.
2 million. 2 million. I'm not talking of a team lead. I'm just talking of a staff engineer, rank and file engineer, who is good at fine tuning in big.
Do you have a LinkedIn?
Which company, sir?
application page?
What is the company name?
Yeah.
Who is giving this much money?
Facebook, for example, Meta.
They will have yes.
You have to really dye the hair really black.
Imagine classification.
Your facelift.
So here, guys, your main thing is, here your main assignment is programming assignments. I've given you fine tuning, image classification with LoRa. I already gave it to you. I'll also give you the assignment that watch the video and programming assignments and learning assignments. Let me add this text here. 1. Watch the video on LoRa. 1. Then 2. Read the LoRa and Q. See, you can't read all the research papers, but at least read these two because you'll find it easy to understand now. Read this. Assignments mentioned below. That is it. So guys, I am a little uncomfortable that I've covered so many topics so quickly. Please help me out here. I want to make sure that you guys learn these things well. So this is it here. And in the direct preference, then there's GaLore. GaLore, did I put the assignment? No. GaLore, let me put an assignment here. Sorry. GaLore Hugging Face article. Face article. Attend Asif's session on the paper reading when it happens. Third, optional. Read the research paper. Fourth is the part, run the code in the notebook, right? Do it either on your 4090 or in Colab or other cloud setup, or your private H100. that's that. Once again, I'm not putting a deadline on this, but please do this. And most importantly, after this, do the direct preference. This is a significant breakthrough, guys. You cannot ignore this. You must do this. Assignment is DPO assignment 1. Watch the DPO video also session. 2. Take the 2 quizzes of DPO video. Read the DPO research paper on DPO. And that is it. So guys, I've left you, unfortunately, with a lot of, quite a few assignments. But if we are to make progress, like you guys wanted us to cover graph neural networks also, we have to move much faster.
Asif,
Go ahead.
can you post all this combined in the Slack, all the assignments? Somebody can.
Okay, I'll copy paste, or actually, I'm a little bit tired. I need a volunteer, somebody who can copy in.
I'll post it.
Okay. So guys, if that is true, then what should be our next milestone? We need to get to agents. I'll keep agents as the last topic, or you want to do agents now before we do graph neural networks? I'm inclined to move to, well, we have diffusion, we have graphs, and we have agents. These are the 3 topics. I feel confident that considering that we have 5 sessions left, we'll be able to cover all of them. We'll just have to move a little bit faster. We'll be able to cover. Let me think which one to bring in next.
Asif, I would recommend agents.
Agents, Asif, yeah.
Yeah. Llama Index just like 5 minutes ago published an excellent presentation with all sample code for agent building.
Really?
I'm going to post that.
Yeah,
in the
please post that. Please post that, and if I'll review it, and then maybe I'll add it to the course portal then.
Yeah.
All right, guys. So with that, it's almost 5:30. I'll take questions in the end. So was the session today useful? We moved at a much faster pace, and I gave a lot of reading assignments for you to do on your own. We covered a lot of territory today.